Hello, Assalamu alaikum. Today I'll be presenting my project on a metro crowd management system. This system is designed to improve safety on metro platforms by automatically controlling the number of people who can enter at one time. You can see on my screen here are the ID and instructions given, and these are our assignment questions which will describe or summarize, and then we'll talk about these problems. Okay, let's here are the deadlines and submission instructions. Okay, here are the answers of my questions. First of all, I would like to discuss about our topic, because the metro crowd management system, this problem we are solving is how to prevent overcrowding on metro platforms. When too many people are on the platform, it can be dangerous. And also, our solution is to build an automatic system that uses a gate to manage passenger flow and keep the platform safe. How it works: if we see, here is given a block diagram, and here are the descriptions given. First, we have an RFID sensor that detects a passenger's ticket. Then we have the signal from the sensor goes to an ADC, which converts it into a digital signal that our system can understand. A synchronous counter keeps a running total of how many people have entered through the platform. Now the FSM, or the finite state machine, it is called the brain of the system. It uses the information from the counter to decide what the gate should do. Okay, after that we use a 555 timer, which will provide a steady clock signal. This makes sure our counter and alarm unit work at the correct speed. If something goes wrong, the alarm will trigger a buzzer. A DSC converts the number of people on the platform back into a voltage. This is to a control room, so a human operator can easily monitor the crowd size. Finally, all of the controls the gate, which is the physical barrier. Okay, if we go to our next question, which is to demonstrate how the FSM transition between idle, check, open and clock states depending on counter values. Okay, if we talk about the FSM, as I mentioned, it's the brain that controls the gate. It's always in one of the 4 states, which you can see in the diagram, which are when the system starts in the idle states where the gate is closed. No passengers can enter or detect at that time. When a ticket is detected, it can move to the check state to verify the ticket. If the ticket is valid, it goes to the open state and the gate opens for one person. After the person passes, it moves to the closed state and the gate closes again, waiting for the next passenger. This cycle ensures that only one person passes at a time. Here are the definitions, how it goes. Here are the HDL code for this presentation. Okay. Now our third question was the alarm should trigger if more than 3 people but 3 passengers cross simultaneously. Okay, if we see on the screen, here it says that actually safety is a top priority. So we included an alarm system. The goal is to detect if more than 3 passengers try to get past the gate at the same time. To do this, we used 4 sensors. The alarm will only go off if all the 4 sensors are triggered simultaneously. We use a simple circuit made with NAND gates, which we can see to the screen, and we used a simple to create this logic. Okay, next the 555 timer control. Here at the screen, if we see, to make sure our counter and alarm work correctly, we need a steady clock signal. We built a circuit with a 555 timer for this purpose. The 555 timer generates a repeating pulse like a heartbeat. We carefully calculated the values of the resistors and capacitors to get the exact timing we needed for our system. Here are the evaluation for the next states and evaluation for the outputs, as we mentioned to the early page. Now here are our 4th number question, which is by showing the 555 timer circuit for the alarm with frequency. From this question, we have to get the values actually. Okay, reporting to the control room TAC. Here are the parts of our mathematical. Here we used by our ID, and the frequency is for 400 Hertz. The time we get 1 by f equal to 1 by 400. It is 2.5 into 10 to the minus 3 second. Our duty cycle, which is Q equal to 100 minus P. From our ID, we got the P is 22, which will be duty cycle 78%. So the DC will be TH by T, it means threshold volt by time, which is DC. Here we got TH, which is 1.95 into 10 to the minus 3, and TL, which will be T minus TH, which is 5.5 into 10 to the minus 4 second. For if we take